So we've got a ladder leaning against a building. So here's my building. Second story window, though. It's a second floor window. So here's our second floor window. And the ladder is reaching the bottom of the second floor window. So here's my ladder. And this is 14 feet up in the air. So this side is 14 feet. And the ladder is 16 feet. So I can also put 16 on this for the ladder right here. What angle does the ladder make with the building? Oh, sorry. This would be the angle of elevation. This is the angle the ladder makes to the ground. What angle does the ladder make with the building? They want this up here. That's what we want to solve for. Okay, so it's a right triangle problem, assuming that the building isn't leaning one way or the other. And so from angle X perspective, we don't have the opposite. We don't know the angle and we don't know the opposite. So we better not do sine and we better not do tangent because both of those involve opposite. We want an equation with just one unknown, the angle. Okay, so instead of sine, tangent is also out. So cosine is the only thing left. Look, this is the hypotenuse, which means this has to be the adjacent. So remember to always put your angle inside the argument of your trig function, inside the parentheses. So the angle we don't know. But that is equal to the adjacent side divided by the hypotenuse side. And so to solve for x, we have to use something called inverse cosine. That cancels out the cosine. So inverse cosine on both sides. So inverse cosine of cosine cancels out. And we got 14 divided by 16. I'm going to make sure my calculator's in radians because I remember seeing that in the instructions. And then my Windows calculator, I hit second, trig. Oh wait, I hit second in here, sorry. Second, and then there's that inverse cosine symbol. So there it is in radians, 0.505. I mean, how many people are actually working on a house and like, hey, what's that angle? You know, that probably happens. But how many people yell back, it's about 0.505 radians? Not too many people, huh?